Have you ever been on the way to the break room or the cafeteria to get your first cup of coffee in the morning and you were interrupted by a couple of users complaining about slowness in their application? Do you ever wonder what's causing that slowness? Do you ever wish that they had gotten you after you got your first cup of coffee? My name's Evans Nicholson. I'm a technical marketing engineer, and I'm going to talk to you about how we can use HPE InfoSight to solve this issue today. In this case, as I mentioned, we have an application team that has developed a new application, and they're doing some benchmark testing. It's not in production yet, but they're seeing inconsistent performance issues. They don't know why, and as I mentioned, they think it's VMware or storage, right? So we're going to take a look and we're going to troubleshoot, and I'm going to use HPE InfoSight to do that. But first, let's walk through the way this application is set up, the way the application designers have told us, okay? So now this is the dev team, right? The dev team, it's not users yet, but the dev team connects into this application through a load balancer. Okay, the load balancer farms out workload to an application cluster. Depending on how busy these servers are, and depending on what they're configured for, which roles they have, the request will come in and go to one of these servers. In this case, it's a load balancer just for performance, right? These both are hosting the same application. And this application cluster is connected to a database cluster. Now, in this case, this is a shared database. So there's another application that is also on this database server. Just important to know. Sometimes the applications have their own, but this is shared. Now, this is a VMware environment, and so we're going to have some storage. We have data stores, data store 1 and data store 2. And we have ESX hosts, right? We've got to have something to run these VMs on. So this is the virtualization layer and a little bit of the database layer. This is pretty well known. This has been around for a while. There's a lot of tools that can monitor this and give you information on the virtualization layer. Now, where InfoSight goes further is that we can tell you which Nimble volume this data store is. And we know a lot of information about this volume, right? This is a Nimble storage volume 1, 2. Now, we call this an infrastructure stack, right? This is the storage stack. This is the virtualization stack. We have this term called cross-stack, and that's what we mean. We're crossing the stack. We're crossing the line between these stacks, and we can connect the dots. Now, because we've added compute recently, we also know that this this ESX host is running on HPE Blade 1. So we've connected the virtualization with the compute stack. So that's the way InfoSight, as I say, our single pane of glass is wider and deeper. And that's just one example of this. And we're going to definitely utilize this setup in this environment. So back to the application. We've asked them to look at the load balancing, and they assure us that these application servers are running the same load. There's not a mismatch or a misbalance of the application. Okay, there's no database issues. And as I mentioned, there's another application cluster, and they're not seeing issues. It's just this application. So we're ruling out the database servers in this case. So we're going to focus on the app servers. And again, what we've got is random performance issues on this application. Load balancing is okay. Let's go into cross-stack analytics for VMware and take a look. So we log onto the portal, and we're going to find app 1. And we're going to note the basic config of the VM. We're going to look at CPU, memory, and just how it's set up, right? So we're going to write that down. We're going to note that. And then we're going to look at some performance charts. Oh, and before we do that, we're going to also note which ESX host and which data store this is running on. So this is app 1. App 1 is running on ESX host 1 and data store 1. Okay, it's important to note. We're going to look at some performance charts on this application server. What we can do in cross-stack analytics for VMware is we can break down network, host, or storage latency. In these performance charts, we see IOPS, throughput, and latency. And this is the latency chart. And we can see, in this case, network layer is fine. And I'm not going to draw this out because I'm going to focus on app 2 in a second. But the point is, we can break down latency by which piece is causing it, host, network, or storage. So application 1 server looks okay. You see throughput and IOPS. In fact, you do want to note how many IOPS and throughput, how much throughput it's doing, right? Just as a benchmark, as performance benchmark. So we do that. We've checked that out. Okay, so now we're going to go to application server 2. And this application server is running on the same ESX host, but a different data store. Okay, important to note. And we check the config, we check CPU, memory, and all that, and they're the same. You use the VMware template, you're smart. These are exactly the same setup as far as the VM goes. So right now, the only difference is they're on a different data store. Then we go to the performance chart. We look at IOPS and throughput, and we notice that there's way less IOPS and throughput on this VM. And we notice super high storage latency. Constant storage latency, not so much on the host or the network, but storage latency. So what's going on with this VM? IOPS and throughput are lower, and they're pretty flat compared to app 1. So what we can do is we can go into the data store and take a look at the data store, because that's different, right? So we're going to go into the data store, and we're going to look at that in cross-stack analytics for VMware. And on that data store, we have similar performance charts, and on that chart, we see high read latency, read and write latency. So that's interesting, good to know. Now, we can also go into the Nimble volume. As I mentioned, we can cross stacks. So we'll go into the storage section of HPE InfoSight and look at the volume. On the volume, we also see high latency. We also noticed, actually from the data store view, we can see VMs, right? Which VMs are on this data store. It's another piece you can get out of the portal. So we see our application app2 VM. We also see 2 other VMs. We're not sure what they are. They're weird names, not sure, but we write it down. It's worth noting. So we're back on the storage piece, right? So we're looking at the Nimble volume. We see some latency. At this point, we could troubleshoot a lot further here, but I'm going to use the easy button. I'm going to use AI performance recommendations from the labs section of InfoSight. So we're going to go into the labs app, the Nimble Storage Labs app, called AI Performance Recommendations. Now, what AI Performance Recommendations is sort of a deep dive, a health check for your storage array. As I mentioned, we know a lot about storage, right? InfoSight started with Nimble Storage pre-HPE acquisition about a decade ago. So we've got a lot of experience on how workloads run on our storage. So a lot of that tribal knowledge, a lot of those smarts are built into this AI performance recommendation tool. The way it works is you go in and you choose a week time frame. In this case, this issue with this new application has been happening for a while, so we'll just choose the last week. And then you choose the array that you want to analyze. Obviously, we'll choose the array which is hosting this volume, hosting all these volumes actually, and we'll hit Analyze. And what we see in this chart, we see a couple things. On the left-hand side, we see performance charts, kind of like we saw with cross-stack analytics. In this case, we see random read IOPS and sequential read IOPS. Okay, I'm just going to abbreviate. And then we see write IOPS at the bottom, right? Read, and write. So what you see is little graphs, time frame, right? Performance graphs. And there's not really happening with sequential read or random read, but write, for sure, there's something happening. So we see this kind of stuff, and this is for a week, the last week. And then we see really obvious spikes of red. Just pretend this is red. It's all over the place. And what that indicates is a high potential impact period. So potential impact is a calculated score that takes into account the time of day, the workload characteristics, and whether or not latency will cause an issue. It kind of does the math for you, right? Not all latency is bad. Maybe your application can handle this kind of latency, maybe not. So potential impact is just a red flag showing you that there might be an issue here. So we definitely see that with the write IOPS. So also in AI performance recommendations are, of course, some details and some recommendations, hence the name, right? So we have details and summary, and then we have recommendations. And in this case, the details are, it says that we're having some write IOPS limiting due to an IOPS limit put on a certain volume. And the recommendations are, if that's okay and that's expected, you don't have to do anything. But if it's a problem and this potential impact, if it's really potentially impactful to you, then move the workload to another volume. And guess which volume has the IOPS limit on it? Volume 2, right? So there's an IOPS limit put on that volume, which is limiting the performance of this application server. So you go back to the team and you report what you've heard, the application team, and you ask them about these other 2 servers, these other names that are kind of weird that are on this data store. And they know whose servers they are. You talk to them, and they, with another storage engineer, set up this volume to have an IOPS limit on it because these are dev VMs, and they didn't want to affect the production workload with a development scenario or a development environment. So they put this on there on purpose. But you, the VMware administrator that configured these VMs, when you're in VMware, you just pick the data store that had the most amount of space, right? Happened to be data store 2 that day, so you provision this VM on that data store. So, as the recommendations say, if this is an issue, and it is an issue, what I think is happening is that when the requests come in and they're on application 2, right? It kind of goes back and forth between application 1 and application 2 server. This application server is limited, right? So those requests are going to be slow. And so what we should do is move this to a volume that does not have the IOPS limit on it. Let's just put it on the same volume that the other one is on. Okay, so now we have everything exactly the same, apples to apples, and we can continue to look and monitor the environment and see if there's application slowness after we've made this change. So we've used HPE InfoSight. We've used cross-stack analytics for VMware. We kind of explored the setup, the config of these VMs. We saw some performance charts, and we saw that there were latency issues related to storage. We did a little bit of troubleshooting at these layers, right from cross-stack analytics for VMware, and then we used the easy button, the lab section, AI performance recommendations, to get this recommendation to move workloads off this volume that are affected by an IOPS limit.